Hello all, welcome to DevOps Sticky channel. In this channel, we are mainly discussing on DevOps related content, both in conceptual and interview based scenarios as well. So, as part of our daily discussions on DevOps, today I come up with one more important topic in Kubernetes, like auto scaling. So, the main benefit of this Kubernetes compared to remaining is like auto scaling. Auto scaling. You guys can guess one more thing, self healing, right? One of the major advantage. So today I want to discuss about this auto scaling. What is the meaning of auto scaling exactly? So whenever there is a bulk traffic or a traffic at peaks at any point of time to our application, to get rid of from the issues, the pods count will be increased automatically. That is the main feature of Kubernetes, right? So how this auto scaling is working properly in the Kubernetes? What is the exact feature or process or strategy we are following to auto scale the pods based upon the load or traffic? If the traffic is in peaks, how it's increasing? If there is no traffic or load to the application, how the pods count is decreasing? So that is the main agenda for today's discussion. Today we have two types of auto scaling in Kubernetes, that is horizontal pod auto scaling, vertical pod auto scaler. Horizontal pod autoscaler automatically increases or decreases number of pods in your deployment based on resource usage like CPU and memory. So if there is peak traffic to your application, how it's auto enabling for auto scaling? If there is no traffic to your application, how the pods are decreasing the count with respect to on what basis means on the basis of CPU and memory. So what's happening is we'll discuss in detail. So just see the what's the difference between HPA and VPA. In the vertical pod, autoscaler automatically adjusts the CPU and memory requests or limits of individual parts. If there was a team, one manager, one lead, and remaining 8 team members means distributing the load to the 8 team members equally. If one of the member feeling pressure, stress upon giving whole work to the one person, and I have team members of remaining 7, so we are team of 8. Is it fine? No, right? So the distribution of work to each individual member satisfied, then only the team will safe, right? Team will be like recognizable without any stress, right? So to adjust the CPU memory request to individual pads is of vertical pod autoscaler. It helps to pod get more resources if needed. If one of the person in the team getting highly loaded means, then we can share that work to the remaining team members, so that the only bulk on one individual person will be reduced. If he need more inputs apart from the site members, if we need all the work is sharing, but the workload needs to be more heavy compared to earlier, then we can add one more member to our team. That's of 9 team members plus lead plus manager. So like that, for the individual pod utilization adjustments, we have vertical pod autoscaler. From the overall pods count perspective based on the CPU and memory utilization, we have horizontal pod autoscaler. But for the drawbacks of vertical pod autoscaler is like, for the to apply the new CPU memory values, the pod must be restarted, which is causing somewhat issues or latency issues or downtime issues for the applications. So when to use this HPA and when to use this VPA? We can use HPA, that is horizontal pod autoscaler, when we have variable traffic load like websites for VPIs. You need to handle many users at peak times. While we have this Diwali offers, Dasra festivals, during that time this Flipkart, Misho, Mitra have more offers. At that time we will make our orders, right? During that time that application will get more users at the peak times. We have big billion days like that. So during that times we can use this HPA. And when we can use VPA means when pods sometimes use more resources compared to than what you set, and you are unsure about what the CPU or memory to allocate for each pod, then it's a VPU. We can come to mostly we use HPA, right? So HPA, there are two concepts: the identical or replica of pod, that is scale out means increasing the pods, scale in means decreasing the pods of same replicas. How it works? HPA means based on the metrics. See here how HPA works means HPA will interact with metric server to identify the CPU memory utilization of pod. Again, metrics, from where the metric server will collect resources means it will collect from the kubelets in the cluster. Kubelet is present in master node or worker node. It's present in the worker node, right? So the kubelet which is present in the worker node of cluster will give information, will have all the information of CPU and memory utilization of each part. That will be collected by metric server. Based on the metric server utilization, the pod CPU count will be increased or decreased. And this HPA controller checks this data. It's in every 15 seconds. It's a default value. And how much percentage of utilization will be more, how we can decide? It's based on the threshold value, like target value that we set in the AML file, and it recalculates the required part count. If the threshold value utilization is of greater than 85% or 75%, whatever you set, upon this calculation, the required part count will be increased, scaled out, or decreased, scaled. HPF formula is like desired replicas. To calculate how many pods will be increased or decreased, to decide this pod count, we have one formula. That is, in your AML, the replica set already sent, right? Like minimum replicas, max replicas. Instantly we can't decide like, okay, you can go ahead for 10 replicas. No, right? If there is no requirement, or if there is no traffic exactly, then what is the use of increasing your count? If there is traffic, if there is no possibility of no traffic means if there is no possibility of decreasing of pods, it's waste, right? So current replicas into current metric by target metric. Already you scheduled threshold value of 60%, currently CPU usage of 90%, you have existing 3 pods. So for every 15 seconds, which was default set by HPA controller, 3 into already have 3 pods, target current metric utilization is 90% divided by target CPU that you shall 60% or 80%. It's upon your project decision. So by this count, it will give 4.5 around to 5 pods, but already existed 3 pods. Since it's 90% means the traffic is going, application users are requesting more, than it's 5. You will increase 2 pods, 3 to 5. And we can have this decision from where this work means scale target reference, that it will take reference from this. See here, we hope everyone know this manifest YAMLs, right? API version, kind, metadata, specifications. So here mentioned t, here mentioned 10 max replicas, and type resource. The metrics will collect a resource of CPU utilization or memory utilizations. That's it will work HPA exactly. So HPA depends on the metric server. Metric server collects all the information of CPU and memory utilization from kubelet, and HPA control checks this data for every 15 seconds. If this uses cross of whatever the set you have, whatever you set of utilization threshold, if it beyond that, it will decide that how much will be count of pods is scaled down or scale up or scale down. That's about the HPA. For example, for real-time e-commerce website, if you take the morning time, it will be low because everyone is busy with the for going office, or not early morning you will go for your shopping, right? So evening sale might be somewhat better compared to morning times. At midnight, night times, it will be low. So how, whatever, it's not same for every time, right? So if first suppose this is example, then how the fluctuations of the pod counts, that's the thing. So metric server API is defaultly not present. We need to install those things. So if you want to see your metric server is installed or not, we can use these commands: kubectl top nodes and kubectl top pods. Metric server, it only show the recent usage, not it show the historical data. This metric server connects to the kubelet running on each node. It collects from C advisor. In the kubelet, as we discussed in just a while ago, the CPU memory utilization of each pod have the information in the kubelet. In the kubelet also, it collects stats from C advisor, which is present in the kubelet. From this only, HPA controller will have all the information of utilizations, and it will exposes them of utilization of CPU memory via Kubernetes API. So this is about horizontal pod autoscaler, and these are like someone have resources metrics, someone have custom metrics. All these things you need to know just to do it's like a task from you only, like how this resource metric will, how these custom metrics will work, that you will so do some work around. So this thing about horizontal pod autoscaler, like how you will calculate, how you will get the percentage, how much threshold you will set. This is about the horizontal pod autoscaler, and we are using this one also. Just go through this manifest YAML as well. API version, what is the version, what is the kind you want to apply horizontal pod autoscaler, what is the name of your application, or what is the name exactly you are referring to, specifications, and scale target reference, scale down or scale up target reference based on this one only. So what is the minimum replicas count, what is the maximum replicas count, how the metrics will take care, how the metrics will decide. Metrics, type, resource, and the resource CPU monitoring, target, type utilization, average utilization of 60% you are telling here. So it will be scale between 2 to 10. That's what. But anyhow, minimum 2 replicas will be in running available. That's the meaning of minimum replicas. Hope this topic is useful and beneficial for you guys who are preparing for DevOps, particularly in Kubernetes. Hope you guys are subscribed to this channel so that you will be notified once I uploaded videos going forward. Keep an eye on this DevOps Sticky channel. Thank you everyone.